Ever wonder how a massive app, like, say, Instagram or even your online banking portal, actually works? On the surface, it seems pretty simple, right? But underneath, it's this incredibly complex machine, often with millions of lines of code. And that's a huge question for any developer. When you have whole teams of people working on the same project, how do you stop that code from becoming a chaotic, tangled mess? How do you keep it from getting so complicated that it's impossible to update or even just to understand?
All right, let's dig into this problem of code chaos. See, when your data, your user interface, and all the logic that makes the app work are all just jumbled together, trying to make one tiny change can feel like you're playing Jenga with a skyscraper. It's super risky, and it slows everything down.
So how do the pros stop this digital Jenga tower from toppling over? Well, they use this really powerful organizational pattern. It's almost like a design philosophy called Model View Controller. You'll usually just hear it called MVC.
Now, to really wrap your head around what MVC is doing, let's just forget about code for a second. Instead, I want you to picture a really well-run restaurant. Behind the scenes, you've got 3 key players, and they all have to work in perfect harmony to get that amazing meal to your table.
So, you're sitting at your table. You've got the waiter who's there to take your order. Out back in the kitchen, there's the chef who's actually making the food. And then, finally, you've got that beautiful final plate of food that gets brought out to you. Each one has a very specific job, right? And they all work together seamlessly. First up, let's talk about the model. In our restaurant, the model is the chef. The chef is the master of the ingredients. That's our data. And the recipe, which you can think of as the business logic. The chef knows exactly what to do with everything, gets all the ingredients from the pantry, which is kind of like the app's database, and makes sure it all comes together perfectly. Then we've got the view. The view is that final plate of food. Its one and only job is presentation. It makes everything look appetizing, but it has absolutely no clue how the meal was cooked. The view doesn't do any work. It's passive. It just displays whatever it's given. And that brings us to the controller. The controller is our waiter. The waiter takes your order, that's the user input, and runs it back to the kitchen to tell the chef what to do. Then, once the chef has the food ready, the waiter is the one who brings that final plate out to you. The waiter is the critical middleman here, managing the entire flow of communication. Okay, so how does this little restaurant crew actually work together inside a real application? Let's follow the flow of information in what developers call the request-response dance. This happens every single time you click or tap on something in an app built with MVC. All right, let's trace a single request. When you click a button on a website, that action goes directly to the controller. The controller acts like a traffic cop. It doesn't handle the data itself. Instead, it turns to the model and says, hey, I need you to go get this specific information. The model does its thing, grabs the data, and hands it back to the controller. And finally, the controller takes that data and passes it off to the correct view, which then builds the final page you see on your screen.
And this right here is the golden rule of MVC. It is the core idea that makes the whole thing work. The model and the view are never, ever allowed to talk to each other directly. The controller is the only one that manages that conversation. This strict separation, well, that's the secret sauce.
And this pattern isn't just for websites, it is everywhere. Think about a media player. When you click the play button, you're interacting with the view. That click gets sent to the controller. The controller then tells the model, hey, we need to update our status from paused to playing. The model then lets the view know, okay, we're playing now, and your screen instantly updates with the new song title and that moving progress bar. See? Same pattern.
So you might be thinking, why go through all this trouble? Why bother separating everything so strictly? What's the real benefit of this separation of concerns idea?
Well, the payoff is huge. First, it allows for parallel development. Your front-end team can be making the view look absolutely perfect, while the back-end team is building the data logic in the model at the exact same time. No waiting around. Second, it's great for reusing code. That same user data model can power the website, the mobile app, and an internal admin tool, all with completely different views. This also makes the whole app way easier to maintain. You could do a complete visual redesign of the UI, and you wouldn't have to touch a single line of the core data logic. And finally, testing becomes so much more reliable because you can test each component, the model, the view, and the controller, all by themselves, in isolation.
Now, this whole thing isn't just some abstract theory you learn in a classroom. MVC is a real-world cornerstone of modern software development, and it powers many of the tools that developers rely on every single day.
Yeah, this isn't some dusty academic concept. If you've ever touched web development, chances are you've used MVC, whether you realized it or not. It's the architectural backbone for tons of the most popular tools out there.
Big-time frameworks like Ruby on Rails and Django, and even front-end frameworks like AngularJS are all built on this fundamental idea. They basically give developers a head start by providing this solid structure right out of the box. That way, developers can focus on what really matters, building awesome new features, instead of constantly reinventing the organizational wheel.
So we've seen how MVC uses this powerful principle of separation of concerns to bring order and sanity to incredibly complex code. And that kind of brings up a bigger question, doesn't it? If this way of thinking can organize a massive software project, where else could it be useful? What else in our work or even our lives could be better managed by clearly separating out the different roles and responsibilities? Definitely something to think about.